So when you're talking about this orchestration, your orchestration is nothing but it is an automated, it is an automation, right? So you are going to automation the process of installation, configuration, okay, all those necessary things can be automated. So that is nothing but is your orchestration. So orchestration is the automated configuration, management, and coordinator of computer systems, application, and services. So that is nothing but is called as an orchestration, which is available there. So we can make use of this orchestration in order to automate the configuration of your application, automate the management of your application services, okay, and the coordination of your computer systems which are available there. Okay, so that is the advantage of using your orchestration which is available there. Okay, so which means that your IT teams managing the servers, okay, and okay, need not manually, manage all this, many servers and applications which are available there. Okay, so in order to manage this complex IT system, okay, you can make use of this orchestration, right, which will help you to manage your manage your applications and so on. So that is nothing but is called as an orchestration, right? So whenever we talk about orchestration, the first and the foremost thing what comes to our mind is nothing but is your Kubernetes. In Kubernetes is comes up here. Okay, so we have different orchestration tools are available there. Okay, so we have orchestration tool from Docker, okay, and also from Red Hat, okay, and Stove, right? So when you're talking about this Docker orchestration, so this Docker orchestration is nothing but it is a set of practices and technologies that will help you to manage your Docker container at large scale. Okay, so that is nothing but it's called as a Docker orchestration. Okay, and so on. So when you containerize your applications, okay, you can scale these applications. Okay, you can scale these applications which are available there. Okay, so when you're scaling your application, which means that you're scaling to a large number of containers which are available there. So in order to manage these large number of containers, you can make use of this orchestration which are available there. So there are different types options are available for Docker orchestration. Like first one is nothing but it's your Kubernetes, and then we have something called as Docker Swarm, and then we have something called as cloud container platforms which are available. Okay, so these are the different options for your Docker orchestration, right? So when you're talking about this Kubernetes, so this is the standard for your container orchestration Jira, okay, and so on. So this will help you to orchestrate your Docker containers to use them, okay, and so on. So using this Kubernetes, okay, platform, you can orchestrate the system, computer systems, your applications, all those things can be done, right? Then comes your Swarm, okay. So this Swarm is comes from your Docker, right? And it is less powerful than your Kubernetes, okay? And but it is easy to use, and also it is readily available for your Docker users who are available, okay, and so on. So that is nothing but it's called as a Docker. Then comes your cloud container platform. So when you're talking about this cloud container platform, we can talk about Amazon Elastic Container Services (EKS), Google Cloud Run, Azure Container Instances. Okay, so these provide you with the basic orchestration capabilities. Okay, so that you can scale up your containerized applications which are available there. So these are the different options of Docker orchestration which is there. So we have Kubernetes, Swarm, and Cloud Container platforms which are available. Okay. So in this, we'll have a look up into what do you mean by Kubernetes. Okay. What is the architecture of Kubernetes? Okay. So we'll be looking into this particular technology in detail which is available. Okay. So, right. So when you're talking about this Kubernetes, these are the concepts of your container orchestration. So these are the key concepts of your container orchestration which is available. So why do we orchestrate? Okay. So the first one is nothing but is your cluster management, schedule management, service history, replication, and health management. Okay, and so on. So these are the three these are the some of the key concepts. Okay, so when you're talking about this container orchestration, the container orchestration will help you to manage your deployment, manage the placement of your container, manage the life cycle of your containers which are available there. Okay, and these are some of the responsibilities which are available there. Okay, cluster management. Okay, so the cluster management will help you to federate your host into one target. Okay, so you'll be able to manage your cluster. Okay, and within the cluster you'll be able to manage all the applications, all the servers, okay, has a one target which is available there. Then comes your schedule management. So schedule management is nothing but which will help you to distribute your containers across your nodes to the scheduler. Okay. So we have a scheduler service. So this service, what it will do is it will schedule your nodes, it will schedule your pods, okay, across your nodes which are available within your clusters which are that is nothing but it's called as schedule management. Then comes your service discovery. Okay. So this service discovery knows where your containers are located. Okay. In which node it is your containers are located. Okay. And also it knows how to distribute the incoming request across to these containers. Okay. And so on. So that is nothing but it's called as a service discovery. Then comes your replication. Replication is nothing but it tells you that the right number of nodes and containers are available, okay, for that particular workload. Okay, so that is nothing but called as a replication. So which means that okay, it ensures that the right number of nodes and containers are running within your cluster. Okay, even if one goes down, okay, let's take for example, by default there should be 3 containers available for an application. Okay, and if one container goes down, okay, so it will automatically bring up the third container which is available there. So at any given point of time, there must be 3 containers must be there. Okay, so that is what your replication will help you. And the last one is nothing but is your health management. Okay, so health management will help you to detect and also it will help you to replace unhealthy containers. And so that is what is. So these are the responsibilities of your orchestration, container orchestration, your cluster management, schedule management, okay, then service discovery, right, replication, and the health management which is available, okay, and so on. Okay, so in this, okay, container orchestration, okay, your Kubernetes is the most used container orchestration tool which is available there, right? So this Kubernetes is a portable, extensible, open source platform which will help you to manage your containerized workloads and services which are available there. Okay, so that is nothing but it's called as the Kubernetes. Okay, and in short, it is also called as K8s. Okay, it is also called as K8s because in between K and S there are 8 letters are available. Okay, and so on. So this meaning of this Kubernetes is nothing but is called as a helmsman. It is called as a helmsman or it is called as a pilot. Okay, it is called as a pilot which is available. Okay, and so on. Okay, so this Google open source this Kubernetes project in 2014. Okay, and so the Google has around 15 years of running their production environment, okay, or production workload on Kubernetes. Yeah, this way. Mm-hmm. Okay. Right. So that is the Kubernetes. So we'll in detail we'll talk about Kubernetes. Okay, what are the architecture? What are the different components are available Kubernetes? How they interact with each other? Okay, how your clusters are contained? How your clusters are created? All these things we'll be looking into this particular chapter. Okay. Right. So what it can do? So Kubernetes provides you with service discovery and load balancing. It provides you with storage orchestration. It provides you automated rollouts and rollbacks. It provides automatic bin packing, self-healing, and secret and configuration management. So all these things you are provided with your Kubernetes. Okay. So right and so on. So when you talk about service discovery and load balancing, right? So you can expose your containers using the DNS name or using your IP addresses, okay, and so on. So the traffic to the container, okay, can be managed with the help of your service discovery. With the help of your service discovery system. Okay. Now, if the traffic to the container is high, okay, Kubernetes able to load balance and distribute the network traffic, okay, so that the deployment is stable. Okay, so that is what your Kubernetes will help you to do. Okay, then comes your storage orchestration. Okay, so now this Kubernetes allows you to automatically, okay, use a storage system of your choice. Like for example, your local storage, you can make use of your local storage. You can make use of your public cloud providers, etc. Okay, and more storages which are available there. So that is nothing but is your storage orchestration, right? Then comes your automated rollouts and rollbacks, okay, and so on. So you can describe the desired state of your application or your container, right? So based on that, you can roll back and then roll out all your applications which are available. So you can change the actual state of your application based on the desired state which is available there. Okay, and so on. So that is nothing but is called as an automated rollout and rollback. Okay, and then comes your automated bin packing. Okay, where you are able to tell Kubernetes how much CPU and memory each container can use. Okay, each container use. You can tell Kubernetes. You can tell Kubernetes that this particular container needs this much amount of CPU and this much amount of memory. Okay, and so on. So all those things can be done. Okay, so that can also be done using your Kubernetes. Then comes your self healing. Okay, so the Kubernetes will automatically restart a container that fails. Okay, and also it will help you to replace the container. Okay, or it will help you to kill the containers that do not respond to your request, that does not respond to your request which is available there, right? Or based on the health environment or based on the user defined health check, the Kubernetes will be able to restart the containers, replace the containers, kill the containers which are available there. So that is nothing but it's called as a self-heal. Then comes your secret and configuration management, right? The Kubernetes allows you to store and manage your sensitive information such as passwords, open authorization tokens, okay, SSH keys, okay, all those, okay. So which means that you can deploy and update your secrets, okay, and application configuration without reinstalling your application or without reinstalling your computer container images which are available. Okay, so that is nothing but is called as a secret and configuration management which is available. So this is what your Kubernetes can provide you. Okay, provide. Okay, so these are the services your Kubernetes will be able to provide you, which is there. Okay, and so on. Okay, so now this is your Kubernetes components which are available. Okay, and so on. So you have your cluster environment. Okay, just a second. I'll just share my screen. Okay. So when we are talking about this Kubernetes architecture, so we have different components are available within the Kubernetes architecture. Okay, right. So okay. So when you are talking about this, there are different nodes are available or different systems are available. Okay, so you have a particular system. Okay, and then you have another system which is there, right? And you might have another system. Okay, and so right. So in order you need to manage these systems, okay, and so on. Either you can manage individually, okay, and when you are in a clustered environment, you need a particular system which will help you to manage all the other systems within your clustered environment. So okay, so in a Kubernetes cluster, okay, you have a master node and you have a worker node. You can have multiple master nodes and you can have multiple worker nodes can be available. Okay, so within a Kubernetes cluster. Okay. So here we have, let's take for example, the master node will be responsible in order to manage all the other worker nodes which are available within the clustered environment, okay, and so on, right? And the worker node is a place where your workloads are deployed, where your applications are deployed, okay, and so on. The master node will be used in order to manage all the other worker nodes which are available or manage your Kubernetes cluster which is there. It is either called as a master node or you can call it as a control plane, which will help you to control your cluster, control your Kubernetes cluster which is available there. So this whole environment is nothing but is called as a Kubernetes cluster. So this whole environment is nothing but is called as a Kubernetes cluster which is available there. So you have your master control plane, and then you have your worker nodes which are available there. Let's say, for example, this is your worker node, okay, one, okay, and this is your worker node two, which is there, okay, and so on. So worker node, okay, and so on. So the master control plane is the place where you are able to what do you call it, manage your work, manage your cluster, manage your worker which is available. So this is nothing but is your worker master control plane which is there. So within your master node, we have different components are available there. Worker node has some components that are available there, right? So so that the master node and your worker node can communicate with each other, and then they can provide all the necessary orchestration which is needed for the cluster can be provided by the Kubernetes which is Okay. So when you're talking about this control plane, there are different components are available there, and and worker node also contains your node components which are available. Okay. So now let's see. So this master node will be able to manage your worker nodes within your cluster. You will be able to manage the worker nodes within the cluster which is available there. Okay. So that is what you will be able to do. Okay, and so on. Right. So now we will deep dive into each and every node which is available. Like for example, we'll talk about what is master node, and then we'll move on to your worker node which is there. Okay, and then we'll move on to and so on, and how they communicate with each other. So all these necessary things we will be looking into each and every in detail. Okay, and so on. So the first thing we'll talk about this master node. Okay, we'll talk about the master node and all the different components which are available within the master node which is available there. Okay, and so on. So when you're talking about this master node, okay, so the master node contains different components which are available there. Okay, right? So it contains your Kube API server, right? So this is an API server component of your Kubernetes, master node or a control plane that will help you to expose your Kubernetes API. That will help you to expose your Kubernetes API which is available there. Okay, that is nothing but it's called as a Kube API server. Okay, so you have a component called as Kube API server. Okay. So what does the Kube API server contain? The Kube API server contains the API server. Okay, it contains a component called as API server. Okay, that will help you to expose the Kubernetes API. Okay, and so on. So this is the and this API server is the front end of your Kubernetes control plane. So this is your control plane, and Kube API server or the API server is the front end of the Kubernetes control plane. Kubernetes control plane which is available. So, right. So you have an API server here. Okay. And within that, you have something called a scheduler services also run. Data. Okay. Right. So this is your API server, right? So the API server is a component of the Kubernetes, which will help you to expose your expose your Kubernetes API, and this is the front end of your Kubernetes control plane. Okay, and so right. So and so on. So right. So that is nothing but it's called as an API server. Okay. So then we have all the other components are available there. So we have something called a kube scheduler is available there. Okay, and then we have something called as okay queue control manager is available there, right? Then we have something called as cloud control manager, and then we have something called as HCD database. And then we have something called as replication controller, right? This has been deprecated actually, and it is been replaced with replicas. But still, I'll explain this particular thing. What is replication controller? Okay. So these are the different components which are available within your control plane. So this is the whole system. The master node is nothing but it's called as a control plane. Okay, so it contains your Kube API server, right? So it has an API server which is available there, okay, which is a front end for your Kubernetes API, okay, and which will help you to expose your Kubernetes API, okay, right? And then we have this Kube scheduler, okay. So what is a scheduler? So this is a component that will help you to watch over for the newly created pods, okay, okay, and so on. And what does the scheduler will help you to do? Okay, they will no, it will watch over that newly created pods, and then it will assign a node to that particular pod. Okay, so it will tell that this particular pod should be available in this particular node. So that is the work of this Kube scheduler. It will schedule that particular pod onto a node, okay, and so on. So that is nothing but it's called as a Kube scheduler, right? And then we have this HCD database, right? So HCD database is nothing but which consists of all the necessary information about the what you call it about your Kubernetes, okay, Kubernetes cluster which is available there, okay. So it is a key value store, okay, which contains all the necessary information about your Kubernetes cluster which is available there, okay. So okay, and so on. So this particular HCD database contains two state of information. One state of information is nothing but is called as a desired state. Okay. Second state of information is nothing but is called as an actual state. Okay. So these are the two state of information which is available in your desired state which is available. Okay, in your HCD data. So desired state is nothing but when you create a container, that is your desired state. Okay, so that is stored in your database. So after it is created, when your container starts running, that is your actual state. Okay, whether your container is running, whether it is in pending state, whether it is deleting. Okay, right. All those things are actual state which is available. Okay. So how does you come to a desired state? Desired state is created. Okay, when you issue a kubectl command, okay, when you issue a kubectl command, okay, so that you are able to create a container, okay, you are able to create a container or deploy a container onto your Kubernetes which is available there. So when you issue this command, okay, what happens is the desired state of that particular container is stored in this particular database, right? And then once you start your container, the actual state is now available. Okay. So now what happens here is the desired state of that particular container and the actual state of that particular container should be okay, at the same level. Okay. So if there is any change at any level of this at the change at the state of your containers, then what will happen is your Kubernetes will now self-heal that particular containers which is available there. Okay, and so on. So that is what your database, right? So in order to preserve these particular state of information, time to time, you need to back up these particular database which is okay, it's available there. Okay. So you need to back up this database and store it to an external storage locations and so on. So if anything happens to your clustered environment, and if you want to, bring back that clustered environment which is there, then you can make use of this particular HCD database which is backed up. Okay, and so on. So that is what is happens here. Okay. So now that is okay. Okay, and so on. So that is nothing but is a desired state and actual state. We'll discuss in detail. Okay, after this, right? And then when it comes to your replication controller, okay, the replication controller will help you to control the number of replicas, okay, which is being created within your Kubernetes cluster. Okay, so let's take for example, you create a container, okay, and you say that at any given point of time, you need three containers should be running of the same image, okay, and so on. So in order to provide load balancing, scaling, and all those, right? So at any given point of time, three containers are running. So this replication controller, what it will do is it will watch over that particular replicas which is being created for that particular application. And if any one of those application goes down, this replication controller will take control, and then what it do is it will create another container so that okay, at any given point of time, you have the same number of containers are running. Okay, now this has been deprecated, and then okay, it has been replaced with replicas. Okay, it is replaced with replicas. So replicas is nothing but the number of containers, okay, you are creating. So if you say three, okay, three containers will be created when you first deploy your application, when you first deploy your containers onto your Kubernetes cluster which is available. So it create three containers okay, and then you execute, okay, and so on. So that is what. So that is nothing but is your replicas which is available. Then we have your Cube Control Manager, okay. So when you're talking about this control manager, okay, which will help you to control the right your processes, okay, your Kubernetes processes is available, okay. So there are no different types of controllers are available there, okay. So when we're talking about different types of controllers, we have something called as node controller is available there, okay, and then we have something called as job controller, okay, and then we have no endpoint controller is there, okay, right, and then we have service account controller is available there. Okay, so you have the service account controller is also available there. And the fourth one is nothing but service account controller. So these are the different types of controllers which are available there. So these are the different types of controllers, no cube control managers which are available there. Okay. So right and so on. So it will help you to control these processes, okay, which is available there. Okay. So what does the node controller do? The node controller is responsible, okay, when your node goes down, okay. So it is responsible for noticing, okay, if the node goes down or okay and so on, health of the node, okay, all those things will be controlled by your node controller. Then have your job controller, which is nothing but it will it will monitor whether the tasks are completed, whether the tasks are completed within your cluster, okay, which is available there, okay, and so on, right? So that is nothing but is called as the job controller. Endpoint controller is nothing but this will help you to provide a link between the services and the pod. Okay, how you are going to access the pods, how you are going to access your applications within the pods which are available. Okay, and then we have the service account controller. Okay, so which will help you to create your service accounts. Okay, in order to provide security which is available. Okay, so you can create either you can make use of your default service account for the namespaces. Okay, or you can create a new service account. Okay, all those things can be. So that is nothing but is called as a cube control manager, which is available. The next one is nothing but is a cloud control manager, right? The cloud control manager helps you to link your cluster to your cloud provider APIs. Okay, cloud provider APIs which are available. Okay, right. So right, so if you want to connect to your Kubernetes cluster on the cloud, you can make use of this cloud control manager which is available there, okay, and so on. So that is nothing but okay, right, and so on, okay, and so on. So when you install your or when you deploy your Kubernetes cluster onto the cloud environment, then you will have this particular component called as cloud control manager, okay, or else it will not be available there. So for example, if you have a Kubernetes cluster on your local laptops, then you will not have this cloud controller manager which is available there, okay, and so on, okay. So that is nothing but is a cloud control manager. So this cloud control manager also have some okay, other controllers, okay, like we have something called as node controller, we have something called as route controller, we have something called as service controller, okay, and then okay, and so on. So what does the node controller do? It helps you to provide, it helps you to determine if a node has been deleted in the cloud or not, okay, or if it has been stopped, okay, and so on. So that is the work of your node controller, okay. Then comes your route controller, right? So you can set up your routes, okay, for your cloud infrastructure, how we are going to access your applications, okay, and all those stuff, okay. And then comes your service controller, where you can create, update, and delete your load balancer, cloud provider load balancers which are available there. So that is nothing but is called as a service controller. So these are all the different components which are available within your control plane. That is your master node. We were talking about this HCD database. Okay, so we are talking about the desired state and the actual state. Okay, now when the container is created, you have the desired state. when it starts running, you have the actual state. Actual state is nothing but is your whether your containers are running, whether the container is in is getting deleted, okay, or it is recreating it, okay. Likewise, that is nothing but is your actual state, okay. So at any given point of time, the desired state and the actual state should be okay similar. Okay. If there is any differences between these two states, then your Kubernetes will automatically create a particular container which is available. Okay, and so on. So how does this? Okay, so the Kubernetes will constantly monitor the state of your no, containers, the desired state and your no, actual state. So this happens in a controlled loop. Okay, it goes on looping structure. So you have your desired state and then you have your actual state. So you have the desired state is there. Okay. So this is your desired state and you have your actual state. Okay. So now what happens is, so these will not get monitored by your Kubernetes in a control loop. So this will be monitored. Okay. So both the state will be monitored by your Kubernetes by control. Okay, in a controlled loop which is available. Okay. So that is what it happens. Okay. So it will check whether both are okay, right? Right. Both are being no, both are in the same state. Okay. So if there is any difference between the state, then what it will do is the container will get restarted, okay, or container will get deleted, or it will help you to create another container, okay, and then it will be available. Okay, so that is how now you need not monitor as an administrator. You need not monitor that particular container. Okay, when the container goes down, you need not worry about what has happened to the container. You need not troubleshoot as an administrator. You need not troubleshoot that container and then start the container once again. You need not worry about it. If the container goes down, it is the job of the Kubernetes to automate that particular container once again, create that container and make it available for the particular user who's available. So that is what. So that is the reason your Kubernetes will automatically watch over the desired state and your actual state in a controlled loop. It will keep on monitoring it. If there is any if there is any differences between the state case, then it will take the action accordingly, which is available. Okay, and so that is the desired state and your actual state is there, right? And okay, let's take for example, if your master node goes down, what happens? Okay, so for all reasons, right, what you need to do is you need to constantly update your back up your HCD database which is available. Okay, you need to constantly update back up your HCD database, right? That is one thing in order to bring it up. So if your master node is down, which means that you will not be able to access the Kubernetes cluster. Okay, so in order to provide a high availability for the master node, it is always a good practice that you have your master node. Okay, 3 master nodes are created upon. Okay, so in order to provide you a quorum, okay, quorum for that particular master node. So you create 3 master nodes, okay, right, within your clustered environment. So if one goes down, other two master nodes are available in order to provide you the access to the clusters which are available. Okay, and so on. So you can have 3, 5, 7, okay, based on that, right, and so on. So that is how you can do it. So this is your master. So within the clustered environment, we have a master node, and we can have multiple master nodes. In the same way, we can have a multiple cluster node can also be available there. Master worker node can also be available. Okay. So the worker node has some components, okay, so that it makes your in order to communicate with the master node makes it much more simple. Okay. So what does it have? It has a kubelet engine. It has a kubelet, and then it has 2 proxy. Okay, and then it has a container management software. Container management runtime. Okay, it's available there with the worker. Okay. So this worker node is a place where your workloads are available there. Okay. So all your workloads are available within your worker node. Okay, the master node doesn't have your workload. Okay, but okay, and so on. But what you can do is within the master, you can have your master node and the worker node on the same system itself. Okay, on the same system, you can have the master node and also the worker node which is available there. Okay, but all your workloads, all your applications will run in your worker. Okay, so where does the application runs? Okay, where do the worker nodes in your Kubernetes? Okay, you have a concept called as pod. Okay, pod. So within the pod, you have your containers. So this is your pod. Okay. So let's say, for example, this is your pod, right? And this is within that pod, you have your containers. You have your containers which is available there. Okay. So you have your containers. So the containers are available within this. Okay. So containers are available. So what does the container contain? Container contains your applications which are available there. So container contains the application which is available. Okay. So you have the pod. Within the pod, you have the containers, right? So the pod can contain multiple containers can be available there. Okay. So the pod can contain multiple containers. So what is a pod here? The pod is nothing but is called as a smallest deployable object in Kubernetes. So this is the smallest deployable object in a Kubernetes which is available there. Okay, so a pod represents a single instance of the running process in your cluster which is available there. So the pod contains your containers. Okay, the pod can contain one or more containers. Okay, such as your Docker containers which is available there. Okay, okay, and so on. So that is nothing but is called as a pod. Okay, so if the pod contains multiple containers, if the pod contains multiple containers which is available there, then what happens is it is not making you are able to share the pod's resources with the particular container. Okay, and so on. You are able to share the pod's resources for the multiple containers which is available there. You are able to share your network. You are able to share your storage resources. Okay, all these things are okay, and so on. Okay, and so on. So each and every pod contains a unique IP address. Okay, and so on. Okay, so it contains a unique IP address, okay, and you can have a network port numbers which are available there, okay, and so on, right? So if you have multiple containers within the multiple containers within the pod, then your multiple containers will communicate with each other using your local host, okay, within your local host which is available there. So you are able to communicate with the containers in a pod, okay, on a local host which is available there. Okay, and so on. So that is nothing but is called as a pod. Okay, a pod which is available there. Okay, and so on. So this pod, okay, can anytime go down and come up. Okay, it can go down and come up. If it goes down, the Kubernetes will be responsible for bringing this particular pod on the particular worker node which is available there. Okay, and so on. Right. Then we have this kubelet engine. Kubelet is running there. Okay. So this kubelet is an agent which runs on each node in the cluster. Okay, which node runs on each node in the cluster. Okay, and also this kubelet, okay, is responsible for no monitoring the pod. Okay, and so on. Okay, and it also makes sure that the containers are running inside the pod. Containers are running inside the pod which is available. Okay, so if the pod goes down, the kubelet will pass on this information to the master node, okay, right? And that particular information will be updated in your HCD database, which means that actual state will be updated, okay? Now the desired state is not equal to the actual state. Once it is not equal to the actual state, what it will happen is the the scheduler will take control, and then it will schedule a new pod in any of the worker node, which is any of the worker node within the clustered environment. Any of the worker nodes within the clustered environment. Okay, so it is not that on the same worker node. Okay, it will create a pod. It will create a pod or container. No, it's not like that. Okay, at any of the worker nodes within your cluster, it will create that particular pod which is there. Okay, and so on. Right. So that is how it gets communicated to your master node and so on. Right. Then comes your kube proxy. This kube proxy is something that is nothing but is your network proxy, which also runs on each node in your clustered environment. Okay, and so on. So in order to implement your Kubernetes service concepts, okay, it is being implemented using your kube proxy, which is available there. Okay. So this kube proxy knows about the containers within the worker node. Okay, what are the containers which are running? Okay, within the node which are available there. So if an external request comes into this particular thing, the kube proxy knows how to spray this particular request to the individual containers so that you will be able to access that particular application which is available. So the queue proxy will help you to forward the traffic, okay, to the respective containers and then to access the applications which are available there. Okay, so that is nothing but is called as a queue proxy. So the kubelet agent and queue proxy will run in each of the node, okay, in each of the worker nodes. Then we have the container runtime management, okay, container management runtime or container runtime. Okay, so this container runtime is responsible for running your containers, which is available. Okay, so like Docker, we have container D or CRIO, okay, or any other implementation, okay, or any other implementation of your container runtime engine which is available. Okay, and so this is your these are the components which are available within your worker nodes. Okay, so now here is some drawback for your pod. Pod has a unique IP address. Okay, and this IP address and the containers, all these things. Okay, your queue proxy knows about all these things. Okay, so when an external user wants to access this, he will be accessing using that IP address. Okay, using that IP address, he'll be accessing that particular pod. Okay, now when the pod goes down and comes up again, 99 percentage what will happen is it will not have the same IP address. Okay, so now what happens here? If it doesn't have the same IP address, the external users will not be able to access that particular pod. So now for that reason, what we are going to do is we are going to have something called a service discovery. We are going to create something called a service discovery, okay, or we are going to create a service, okay, outside of your Kubernetes cluster. Okay, service discovery will be creating a service discovery. Okay, so what the service discovery will contain? The service discovery will contain all the necessary details about the pod details, okay, IP address of the pod, all those things will be available there. Okay, so this pod contains a dynamic IP. So once it goes down, it becomes a new IP address. But here, when you are creating a service discovery, you are creating a static IP for this particular pod. For this particular pod. So at the back end, even if this pod goes down and comes up with a new IP address, it doesn't matter because we have already assigned an IP address, static IP address for this particular pod which is available there under your service discovery, under your service. So using the service discovery, we'll be able to access the same pod once again. Okay. If this service discovery is not available, then what you need to do is you need to manually update that particular IP address for your inside your queue proxy, so that what will happen is the external users will be able to access that IP address, and then you will be able to access the pod which is available. So each and every time when the pod goes down, you need to update, and you need to update all the users who are client who want to access the pod. All those things we have to do that. So in order to avoid that particular difficulty, okay, we are extracting that particular service data stuff, okay, and then we are providing a static IP address for this particular pod, okay, and so on. So even if that at the back end, if the pod goes down and comes again as different addresses, okay, it doesn't matter for us because we have already assigned a static IP for that particular pod, okay, and so on. Okay, got it? So this is how you are able to access your pod within that. Okay, so if there are multiple containers within the pod, okay, the multiple containers will have the same IP addresses. Okay, okay, all the containers will not have different IP addresses. It will have same IP addresses. Okay, same network addresses, same host names. Okay, all these things will be there because it is sharing the pod's resources. The container is sharing the pod resources. So because of that, it will contain the same IP addresses and so on, right? So if you want this one container to communicate with the other container, it will container you can communicate using your local host and also the port number. Local host and the port number. It will make use of this local host and the port number, and then it will communicate with the containers which are available. Okay, got it? But only the pod will have a unique IP address. So let's take, for example, if you have another pod, okay, so this pod will have another IP address, and this pod will have another IP address. Okay, so there are also some add-on services are also available there. okay, like for example, your DNS services, okay, right, your, okay, you can have a cluster DNS, okay, or a DNS server in your environment, okay, and so on. All those things can be provided, and then you have, okay, then you have your web user interface, that is your dashboard, okay, web UI, okay. So you have a dashboard, right? So using this UI, you can manage your Kubernetes cluster, okay, and troubleshoot your application which is running in your clustered environment which is available there, okay, right? So all these things are some of the add-ons which are available there. So you can make use of these add-ons, okay, and so on, right? So you have your kind of, container monitoring, okay, and then you have cluster level logging, okay, logging add-ons, okay. All those things will help you to monitor your cluster, Kubernetes cluster, and also it will help you to save your container logs, okay, onto a central logging store which is available there, right? That's so, right. So all these things are some of the add-on services which is available within your Kubernetes cluster environment, okay, and so okay. So now when you're talking about Kubernetes, right? So we talked about Kubernetes which was available there, right? So you know that the Kubernetes runs your workload, that is your application is running, okay. So now in order to store your application data, you need to have a storage, okay. You need to have a storage where you are able to store your application data, okay. But your Kubernetes or your Kubernetes cluster data is stored in your HCD database. So, okay, in the same way, you need to store your application data. Okay, where it can be stored, you need to have a storage location, or you need to have a volume where you need to store your storage. Okay, where you need to store your application data. Okay, so now there are different types of volumes are available for your Kubernetes. Okay, so when you're talking about different types of volumes, okay, it can be internal to the Kubernetes cluster, or it can be to the external to the Kubernetes cluster which is available there. Okay. So when you're talking about internal to the Kubernetes cluster, we have something called as, okay, we have some volumes called as host path, okay, and then we have empty directory. Okay, so these are the two what I call as volumes which are available there. Okay, internal to your cluster or internal to the pod. So we say empty directory. Okay, second one is nothing but it's called as a host path. Okay, and then for external thing we have something called as, okay, cloud volumes. Okay. And then fourth one we can have NFS, and then fifth one is nothing but is called as a PVC. Okay, so PVC is nothing but is called as a persistent, okay, persistent. Okay, so these are the 5 different types of volumes which are available there. Empty directory host path, which I can consider that which is internal to your Kubernetes cluster or internal to the pod. Cloud volumes, NFS, and persistent volume 3. Okay, so these are the 5 volumes, the storages which are available, types of volumes which are available there, where you can persist the state of your application, okay, and so on. State of your application which is available. Okay, now when you create a pod, your empty directory volume is automatically created. Okay, by the word, which means that the directory is empty. Okay, directory is empty and so on, right? And this directory is available within the pod itself. Okay, so you create a pod. Okay, you create a pod. Okay, so once you create a pod, within that pod, we have a volume which is created automatically. Okay, so that volume can be considered as a empty directory. Okay, so now what happens? This is within your pod. Okay, so the application state is stored in this empty directory which is available there. Okay, so now what is the drawback is if the pod goes down, okay, since this volume is within the pod, your empty directory volume, this particular volume will also go down. Okay, when this particular volume goes down, together with it, your state of your application is also lost. Okay, the data is also lost, which is available there. Okay, and so on. So that is the drawback. Okay, then next comes your host path. Okay, host path is okay. Host path. you have to mount a volume to this particular. Okay, let's take for example, I'm mounting this F directory. Okay, or within that, okay, application data. Okay, so I have to mount this particular path which is available there. Okay, I have to mount this path which is available. That is nothing but is your host path. Okay, so you have to provide a mount point where you are able to mount that particular directory has a volume. Okay, and this host path is also available within your pod, which means that if the pod goes down, together with that, the volume, host path volume also goes down and the data is also lost. Okay, and so on. So, in order to avoid this particular difficulty, they came up with the idea of providing the volume outside of your pod environment, okay, or a clustered environment which is available there, okay, and so on. So that is okay, and so on. So we have this cloud volume. Cloud volumes is nothing but your storages which is available in the cloud, okay, like elastic block storage, EBS, okay, object storage on the cloud, file storage on the cloud, block storage on the cloud, okay, and so on, right? So okay, and so on. So this Kubernetes can connect to that particular cloud volume and then store the state of your application onto the cloud volume which is available. Okay. Now, if you want to connect this particular pod to the cloud volume, okay, what you need to do is you need to abstract some detail from the cloud storage. Okay, you need to check what type of storage, okay, is available on the cloud. Okay, your no, security related stuffs. Okay, how you are going to connect it. Okay, what is the user ID and password in order to connect to that particular storages. Okay, right, and all those things. Okay, all this necessary information has to be abstracted, and then you have to make use it with your Kubernetes, and then get connected with your cloud volumes which are available. Okay, and so right. So that is one thing. And then we have this NFS. NFS, network file storage, is also the same thing. You create a network file storage, okay, and then provide the information where your network storage is available there, okay, and then right, ask your Kubernetes to connect to that particular network storage, NFS, which is available there. Okay, so the NFS can also be a PVCs, persistent volume claim. I'll tell you what you mean by persistent volume claim. So this is the most important concept of your Kubernetes. Okay, and so on. So this persistent volume claim is nothing but it is a request for a storage. Okay, by a developer. Okay, so the developer, what he does is he requests for a storage for his project. Okay, and so on. Okay, and then the Kubernetes, what it will do is he will assign that particular storage for that particular project is available there. So that is nothing but it's called as a persistent volume claim. Okay, so what you're claiming the persistent volume. Okay, so the persistent volume is nothing but is your storage. Okay, so you're making use of the persistent volume claim. And then you are sending a request for a persistent volume. Okay, you are sending a request for a storage which is available there. So that is nothing but is called as a persistent volume claim. Persistent volume claim which is available there. Okay, and so on. So this persistent volume claim, okay, is used by the developer to request for a storage, a storage which is available there. Okay, and so on. So that is what is nothing but is your a persistent volume claim which is there. Okay, and so on. Okay, so now, right. So what happens here is in your deployment. Okay, when you're deploying it, you provide the persistent volume claim. Okay, you provide how much memory you want, how much storage you need. Let's take for example, I need a 10 GB of space. I need. Okay, I provide the storage class. Okay, storage class tells you how to access your storages. Okay, either it can be provisioned in a static manner, static provisioning, okay, or dynamic provisioning. Okay, so you can dynamically provision your volumes at the backend which is available. So when I deploy my application, okay, or deploy my container, I provide the necessary, okay, what it called as I create a necessary persistent volume claim. So in the persistent volume claim, I provide the space, memory space which is available there, okay, and so on. So now what will happen is, let's take for example at the back end, I have a storage, okay, let's take for example, I have around 1 TB of space, this memory space is storage space is available there, okay. So I have 1 TB of storage space. In that 1 TB of storage space, what I need is I need only 10 GB for my particular project, okay, and so on. So right, so which means that what it will do is when I request for a storage place, okay, so Kubernetes will provide or assign a volume, okay, from this particular storage space. That is, it will assign only 10 GB of space will be assigned to this particular project which is available. Okay, so all the other memory spaces are available there, which can be used for by other projects who are available there. Okay, other projects and so on, right. So you can make use of this particular thing. Once done. Okay, and then what you can do is once your project is over, right, and then you do all this data are not needed in your project space, you can take a backup and then you can release this particular space. Okay, so when you release and when you reclaim this particular space, which means that now the space is available for the other projects to be claimed. Okay, other projects to be claimed, which is available. Until then, what happens here is this particular spaces will not be assigned to some other project which are available there. Okay, so you will not have some other project is requesting for a storage place. So all the other storage space which are free will be assigned to that particular project. Okay, except this particular storage space. So that is the power of PVC, persistent volume thing. Okay, so you are sending a request in order to claim the volumes which are available at the backend and so on. Okay. So that is nothing but is called as a persistent volume claim. Okay. So PVC is nothing but you are sending a request for a storage. Okay. Storage, that nothing else. Okay. And this is done by your developer. So the developer will request for a storage volume. Okay. So the developer requests for a storage volume, okay, using your PVC. Okay, so and then you assign. Okay, instead of now assigning this whole 1 TB of storage space to a particular project, we are assigning only what is needed for that particular storage capacity. Storage, okay, for that particular application. So that is nothing but is called as a PVC, persistent volume claim. So you have your application. Okay, how to deploy your application onto the what you call as onto your Kubernetes environment. Okay, so when you want to deploy your application onto Kubernetes environment, okay, you can make use of this kubectl command. Okay, and then you can create a YAML file. Okay, for the deployment option. So you can just say deploy.yaml file. You can run this particular command. So you can say kubectl-f. Okay, and then you can deploy.yaml file. What is the deploy.yaml file contain? The deploy.yaml file will contain all the necessary configurations in order to deploy your applications onto the Kubernetes environment. Okay, so once you deploy this particular application, okay, you need to create the service. So in order to create the service, what you do is you create a service.yaml file and then run that particular YAML file using this kubectl command which is available. Okay, and then after that you create a route option. Okay, route.yaml file where you are able to access that particular containerized application using the routing. Okay, options that are available there. Okay, so you are able to create. So you have to run all this, all this particular things in order to deploy your application and start accessing your applications that are available there. Okay, so if there are any other configurations has to be done, okay, that can also be done. By creating by creating another deployment. Okay, by creating another deployment. Okay, within your applications which is available there. So all these things can be done, which will help you to deploy your applications onto your Kubernetes environment. So at the tandem, what you have to do is first you have to run your deploy.yaml file, then you have to run your service.yaml file, and then you have to create a routing. Okay, and so on. So this route will help you to access the application. Access your application within your containerized environment. Okay, and so on. So that is nothing but equal to the Kubernetes deployment which is available, right? So even this can be simplified. Even this can be simplified, okay, by using another method called as Helm, okay, Helm, okay, and so on, okay. So you can make use of this Helm package, okay, which is a tool which will help you to install and manage your Kubernetes application, okay. So what you can do is within that Helm, okay, what you can do is you can you can create a deployment, okay, the service.yaml file, okay, okay, all those things can be created onto a single file, right, and then you can make use of this Helm and then install that particular application onto the Kubernetes environment, okay, right. So that can be done, okay, so that can be done, it is available, okay, and so this, okay, and so on. And there is also another concept called as operator concept, okay, right, operator, will be discussing about this. So this operator can be used in order to deploy your application and manage your application, okay, and so on, right. So when you're deploying your applications on your Kubernetes environment, okay, so you may have there are different types of applications like stateful applications and stateless applications, right, stateful application and stateless application. The Kubernetes is can be used when you deploy a stateful application. Kubernetes can you can make use of this Kubernetes in order to manage this particular stateful applications which are available there, okay, and so on. If you're talking about stateful applications, right, so what happens is to manage your stateful applications using your Kubernetes, okay, right, okay, it is really a difficult task for you, okay. So in order to manage your stateful applications, still we need to do some manual tasks in order to manage your stateful applications, okay. So when we do our manual task, what happens here is, okay, the whole concept of orchestration is goes off, okay, and so on. So, in order to manage your stateful applications, they came up with the idea of operator. Okay. So this operator will help you to manage your stateful applications which are available. Okay. So manage your stateful applications, install your stateful applications, update your stateful applications. All those things can be done with the help of your operators. Okay, and so on. So okay, and so on. So that is so these three methods you can deploy your application. Either you can deploy using your kubectl, either you can make use of your Helm tool, or you can make use of your operator which is available there. Okay.